Welcome to ECE 111. In this class, we're going to be going over a program called Matlab. Now, Matlab is basically a calculator on steroids. It's a program that's extremely powerful and has become the industrial standard in electrical computer engineering. In fact, most of engineering uses Matlab. Some of the feedback we've gotten from our students is it would be really nice to have a course that covers MATLAB before we assume that you know everything about MATLAB. That's what this course is. And we're not going to cover everything about MATLAB. That would take a couple of years. But this will at least get you started, be able to write some programs in MATLAB, use it like a calculator, solve different types of problems. That's really the point behind ECE 111. In this lecture, this is the introduction to MATLAB. Now, the goal is to become familiar with MATLAB. That's using the command window. Basically, the command window is like a calculator. You can type in your operations and do what is 2 plus 3, what is 2 plus 3 times 7, so on. How to use scripts. A script is a file that basically has commands that you would type into the command window. So then, rather than having to type in all the commands, you can just run the script, and it's like you typed them in all at once. We're going to look at plotting in MATLAB. MATLAB is basically a graphing calculator. It's got really good graphics. In addition, you can do things like random numbers. I can generate random numbers and roll 6-sided dice, 8-sided dice. I can program it and make it a loaded 6-sided die, such as 20% of the time, I'll always roll a 6. We'll look at for loops. If I want to do a set of commands over and over again, a fixed number of times, that's a for loop. A while loop, keep running until an event happens, like roll a 6-sided die until I get a 1. And a Monte Carlo simulation. Now, this is one of the powers of MATLAB. If you want to figure out the probability of something, I can take the courses and calculate it, or what I could do is set up a program that runs the event one time, like roll a 6-sided die. To figure out what the odds are, now roll the dice 100,000 times. And the probability is roughly the number of times that the event happened, like the number of times I got a 1, divided by the total number of times I rolled the dice. That's called a Monte Carlo simulation. So that's what we're going to do this week. Now, starting out in MATLAB, this is what MATLAB looks like when you first start it up. You've got the command window. This is where MATLAB acts like a calculator. I can do things like what is 2 plus 3 and find out the answer is 5. I've got the list of the programs in my current directory. And the .m, these are files that I write. We're going to talk about that a little bit later. These are my variables. And here's the list of my previous commands. Now, actually, I don't care about most of this. So what I normally do in MATLAB is close that down, close this down, close that down. So I just have the command window. That's really what I want MATLAB for. In the command window works like a calculator. With it, you can do operations. For example, I can say, what is 2 plus 3? The answer is 5. What is 5 times tangent of 6 over 2? Get an answer. So it's a calculator like any calculator you've seen. There are names of operations in MATLAB. For example, pi is spelled pi. E to the x uses the syntax exp of x. Again, MATLAB doesn't really do exponentials terribly well, so it uses exp to mean e. If I want to do 10 to the x, that'd be 10 caret x. Log of x is spelled log. Log base e is spelled log in MATLAB. Log base 10 is log 10. You've got sine, cosine, tangent. The thing to note is MATLAB uses natural units, radians. Pretty much you're going to find that anything English is wrong. In English we use degrees. Degrees are not natural units. The math works out a whole lot better if you use natural units, and MATLAB likewise uses radians. You've got sine, cosine, tangent, arcsine, arccosine. Actually there's thousands of other commands. MATLAB also respects the order of operation. If I do something like this, what is 3 plus 4 times 5 squared? Powers happen first. This will do 5 squared times 4 plus 3. It never hurts to use parentheses, so I could say, what is 5 squared? Make it clear, that's what I want to do first. Then I want to multiply by 4. Then I'll add 3. Again, it never hurts to use parentheses. If I have confusion, like what is 4 times 7 over 2, let's do it this way, 4/7/2. Matlab executes left to right. What this actually does is 4 divided by 7, does that operation first, then divides by 2. If I wanted to change it, such as 4 divided by 7 halves, it's better to use parentheses. Again, it never hurts to use parentheses. Sometimes it helps. The parentheses make it clear which operation is done first. So, what you can do with Matlab? Matlab is basically a calculator. For example, this is a problem you're going to run into when you take 321 analog electronics. I've got a light sensor. What a light sensor is, it's a resistor. And the resistance varies with light level. So this is a symbol for a resistor, that's R. As the light changes, R changes. I can have a voltage divider. So if I have 10 volts, again, this doesn't have to make sense for you currently, just rely on the equations. That's the beauty of math. But this is where the equations come from. I've got a voltage divider, 2 resistors. I'm going to measure the voltage. As the light level changes, R changes by this equation. As R changes, the voltage changes by this equation. Suppose the room is at 10 lux. What's R, what's V? Well, in Matlab, I can find that. I would say lux equals 10. Again, Matlab's a calculator, and I can assign variables to different values. I can say R is 2200 divided by lux to the 0.6. And here, technically, the parentheses isn't necessary because of the order of operations. But again, parentheses don't hurt. Makes it clear, you do the power first, then divide. R is 552 ohms. Now find V. This is going to be 3.55 volts. And that's one use of Matlab. Now Matlab is a matrix language. If I want to start a matrix, I would do a square bracket. A comma means next column. Semicolon means next row. And a single quote means transpose. If I take out the single quote, my lux is going to be 10, 20, 30. If I transpose it, it gets rotated, becomes 10, 20, 30 as a column matrix. Now as a matrix language, when I multiply or raise to a power, it does a matrix multiply, matrix power, which you'll get to when you take Math 129. Here, if I want to do a bunch of operations at once, I don't want to treat that as a matrix. I want to treat that as 3 separate numbers. In Matlab, the syntax for using separate numbers is dot. So dot times, dot slash, dot power. That tells Matlab that don't treat this like a matrix. Treat that as 3 separate numbers. Do the operations on each number separately. So suppose I want to find out what's the resistance and voltage at 10 lux, 20 lux, 30 lux. What I could do is repeat the previous page 3 times, or I can set up a matrix. If lux is equal to 10, 20, 30, here's the resistance, and it finds all 3 values at once. Here's the voltage, finds all 3 values at once. So it's kind of convenient. You can format the output. Now Matlab has, I think, 18 decimal places. Actually, let's count it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Matlab has 16 decimal places. If you want to see them, just do format long, and you see all the decimal places. There's also format short E for exponential notation, short engineering for engineering notation, where these are power of 12. And another notation in Matlab, E. This means exponent. If I want to do a number like a million, what I could do is 1, 0, 0, 0, 0, 0, 0. That gives me 1 million, or 1E6. That means 1 times 10 to the 6. 4.67 E5 is 4.67 times 10 to the 5th. So that's just a convenient way of typing in numbers in Matlab. This is 4.67 exponent 5, meaning times 10 to the fifth. Now, MATLAB has really good graphics as well. What graphs do is, if I know the actual value of the lux, I can calculate R and V. Suppose I don't know. I just know that the lux is going to go somewhere between 0 and 100. 100 lux is basically room light, 0 lux is pitch black. What's the resistance as lux varies between, say, 1 and 100? Well, what I can do in MATLAB is I can say, let's have the lux go from 1 to 100, steps of 0.1. So this actually has 1,000 elements in that matrix. I can then calculate R. Using the dot notation, calculate the resistance at each light level. Then plot. When you plot, that plots x versus y. The x-axis is lux, the y-axis is resistance. And I can label the axis. Usually it's good to label the axis, because otherwise nobody knows what you're plotting. So x-axis is lux, y-axis is ohms, and here's what it looks like. What graphs do for you is I can sit there and see what happens. If the lux goes below 10, the resistance shoots up, and then it drops. What graphs also do is they let you go backwards. If I know lux, I can find R. If I know R, I can find lux. And there's two ways to space this data. This is a linear spacing. It changes by 0.1. This is a log spacing. So there's 100 points between 10 to the minus 2 and 10 to the plus 3 with even spacing. On log spacing, it's a constant multiplier. Like each number is 5% bigger than the previous number. So what you can do with MATLAB as a graphing calculator. Graphs are really useful. They show you how two variables are related. They allow you to determine, in this case, how voltage is related to lux. And unless you go backwards, it lets you determine lux in terms of voltage. So again, if I took that voltage divider, this is how a light sensor actually works. I have a known resistor, I have a light-sensitive resistor, and I measure voltage. Voltage is one of the few things you can actually measure. Well, I can see in MATLAB how does voltage relate to lux. I've got lux going between 1 and 100, steps of 0.1. Calculate R, calculate V. I'll now plot lux versus voltage. And here's what it looks like. So again, what this tells me is that if I'm at 10 lux, here's my voltage. If I'm at 20 lux, there's the voltage. 30 lux, there's the voltage. It also goes the other way around. If I read 4 volts, it tells me this is the light level. If I read 2 volts, that's the light level. Now to plot, there's a couple ways to plot in MATLAB. If I do plot x versus y, that does Cartesian coordinates, where here's the x-axis and here's the y-axis. And if I have a function in this form, that plots as a straight line. I can have the x-axis on a log scale. What that does is log functions plot as a linear function on when x-axis is a log scale. I can make the y-axis a log scale. And the reason for doing that is exponentials are plot as straight lines if I plot them on semi-log y paper. I can make both axes logarithmic, in which case power functions become linear. And I can do subplots, have 3 different plots on the same page. That's actually not really necessary. In your homeworks, if you go down here and type in snipping tool, S-N-I-P, try that again, S-N-I-P, there we are. That's the snipping tool in Windows. If you have a graph and you want to copy it into Microsoft Word, I'm going to say I want to take a new plot, take my graph right here, and then I can copy and paste that into my Word document. So it really isn't necessary to do subplots in this class, but other classes you might want to get a couple different plots on the same graph. You can do that in MATLAB. And here, for example, if I do subplot 3, 1, 1, that's the 3 by 1 matrix of plots. Here's the first plot. plot x versus y. 3 by 1 matrix, second plot right here. Plot x versus y as a dot. Third plot right here, plot x versus y as a dot plus a line. Now, if you want to know all the different features of plot, Matlab has really nice help features. If I say help plot, it'll give me more information than I wanted. I can plot lines and I can specify the color of the line. I can specify how the points are marked. I can specify what kind of line it is. So again, if you ever get stuck in Matlab, just do help. And it usually tells you what you need to know. Usually tells you more than you need to know. In addition, when you plot, you can plot multiple curves on the same graph. And the excuse me, the syntax would be plot x1 versus y1, x2 versus y2, x3 versus y3. That's one way to do it. Or if all the x's are the same, I could say plot x versus the matrix y1, y2, y3. And that'll plot x versus the first column, x versus the second column, x versus the third column. For example, suppose I invest $1,000 or deposit $1,000 in the bank and I collect 1%, 3%, 6%, or 9% interest. How much will I own, or how much will that be worth after 0 to 10 years? Well, to determine that, I can have time go between 0 and 10 years, steps of 0.01, column matrix. At 1% interest, it's my initial value increasing as e to the at. At 3% interest, it's $1,000 increasing as e to the at, 6%, 9% interest. Now plot. I can plot time versus y1, time versus y3, time versus y6 or y9, or in this form, either one works. They both give you this graph. So here's your 9% interest, 6% interest, 3% interest, and 1%. And here you kind of see that interest rates make a huge difference. If I can get 6 or 9% interest, I'm going to have about 9% interest, 2.4 times as much money I'll have at 1% interest. So compound interest is really powerful. Matlab can do polynomials. Now we're going to use polynomials a couple times in this class. What poly does is it says, give me a polynomial that has roots at a, b, and c. For example, suppose I want to find what polynomial has roots at +1, +2, and +3. If I type in poly of, and then I have to give a matrix. So this just wants a single variable. The variable will have 3 elements in it, my 3 roots, 1, 2, and 3, and it kicks back a matrix. Now again, Matlab is a matrix language. When you program it, it's really hard to program polynomials. With computers, it's really easy to program matrices. So Matlab gives you the answer as a matrix, and what this means is this is decreasing powers of x. So there's your x cubed term, there's your x squared term, x and 1. So this is the polynomial that has roots at -1, -2, -3. The inverse of roots, or poly, is roots. What roots does is, given this polynomial, what are the roots? If I try it, I get the roots are +1, +2, +3. So these are kind of like the opposites of each other. Graphically, what roots are the zero crossings. If I say, here's my polynomial, x cubed minus 6x squared plus 11x minus 6, plot y versus x between 0 and 4, and here's what you get. So there's y, here's the x-axis, here's the y-axis. And note that the zero crossings are at 1, 2, and 3. The zero crossings are the roots. So here's a problem. If I want to find the zeros of a polynomial, I can find that using the roots command. Suppose instead I want to find out, when is this polynomial equal to 6? Well, that's a problem. In Matlab, there is a function equals 0 command, that's roots. There is no function equals 6 command. So to solve this problem, I need to change the problem to fit the solution, bring the 6 to the right-hand side. Now I have polynomial equals 0. That's roots. And this is very typical in engineering. I need to change the problem to fit the solution. So to find out when this is equal to 6, what I'll do is input my polynomial, this guy right here. That's your 1x cubed, 5x squared, 7x and 2, 1572, minus 0006. For matrices, when I add and subtract, these have to have the same dimensions. What this means is 0x cubed, 0x squared, 0x plus 6. Now these are both 1 by 4 matrices. I can subtract them. And the roots are when the original problem equals 6. So there's 3 roots. 2 are complex, 1 is real. That's the one I want. And I can check. If I say x is the third answer, and plug it in, x cubed plus 5x squared plus 7x plus 2 is 6. So that's one use of Matlab. Matlab is basically a graphing calculator. Matlab has a lot of other features though, and that's kind of what makes it so powerful. In Matlab, there's a thing called scripts. So if I go over to Matlab and do File, New, Script, I get a blank window like this. What a script does, let's get this over so you can see it. A script is like I type something into the command window. So if I say a is 2 plus 3, give it a file name. If I execute the script, it's like I type this over in the command window, and the answer is 5. If I stick in a semicolon, this does the operation, saves it, but doesn't display it. So here, it displayed the answer twice. If I run it this time, it ran the code, but nothing happened. Well, actually that's because I told it don't display anything. Now I calculate A, and it tells me, yep, there's the answer, 5. What scripts are nice for is it makes it easy to write your code and debug it. So rather than having to type stuff over here over and over and over again, put it in a script. I can then execute it with this green arrow, or for whatever I name the file, in this case I called it script demo, I can call that in the command window. When I call it, it's like I took this code and inserted it right there, and it ran it. So what this code does is it takes x, goes between 0 or minus 2 and plus 2. Y is x plus 1 times x minus 1 times x minus 3, and then display x versus y. So here's what you have. This is your x, there's your y, there's my data. And we're going to be using scripts quite a bit in just a little bit. So let's have some fun with scripts. Let's start rolling some dice. To roll dice, I need a random number generator, and oddly enough, Matlab has some pretty good random number generators. Now, there's actually 2 ways to generate random numbers in Matlab. There's the function rand and randn. So for example, let's go back over here. Let's have a is just a random number. When I run this, every time I run it, I get a different number between 0 and 1. That's rand. There's randn. That's a Gaussian distribution. This is your bell-shaped curve you've seen over and over again. This goes from minus infinity to plus infinity. Most of the time it's close to 1, or close to 0. For dice, I want to have this function, a uniform distribution between 0 and 1. If I want a 6-sided die, I'll multiply by 6. Actually do it this way. Let's have 3 dice. This creates a 1 by 3 matrix of random numbers. Every time I run it, I get a different random number. Multiply by 6, and I get numbers between 0 and 6. Now let's round up. There are 3 different commands for rounding in Matlab. There's ceiling. What ceiling does is take these numbers and round up. So 1.5 rounded up is 2, 5.04 rounded up is 6, 1.5 rounded up is 2. That's ceiling. Floor is round down. 1.54 becomes 1, 5, and 1. And then there's also round. round to the nearest integer. What we're going to be doing is ceiling. I want to round up. That gives me numbers between 1 and 6. So now when I run this, those are my 3 6-sided dice. And I can also do 8-sided dice. If I add them up, the command sum, I get the sum of 5 6-sided dice. So that'd be like the damage done with a level 5 fireball. There's an if statement. So if I want to roll fair dice, I can use the rand function. Suppose I want to roll a loaded die, such as 20% of the time I roll a 6, the rest of the time it's fair. That'd be this command. There's an if statement. What the if statement does is if a condition is true, execute the following statements, terminated by an end. There's also if then else. If statement is true, execute the following code, otherwise execute this code, end. And you can also have else if. Now the stuff in here has to be Boolean operation, true and false. That could be like if n's equal to 3. Here in Matlab, double equals is compare. Single equals is assign. That's true in C, that's true in Matlab. There's greater than 3, greater than equal to, not equal to, bigger than 3, and less than 7. So suppose I want to roll a 6-sided die where it's loaded. 20% of the time I get a 6. That would be this code. I'm going to pick a random number. If it's less than 0.2, or 20% of the time, my answer will always be a 6. Otherwise, it's a fair 6-sided die. Then display the answer. When I run that, I got a 6, 4, 3, 2, 6, 5. Every time I run this, I get a different number. It's random. But it's loaded. I get a few too many 6s. Well, given that code, that's an if statement. Suppose I want to roll 8 6-sided dice. That's a for loop. What a for loop does is it executes code a fixed number of times. So for example, if I have this code where I equals 1 to 100, I is going to count. First time through the loop, I equals 1, then 2, then 3, then 4. It'll execute this code 100 times. So using that, suppose I want to cast a level 8 fireball using loaded dice. Now if I had fair dice, what I could do is this. I have a level 8 fireball, 8 6-sided dice. So there's my 8 dice. Now add them up. This is the damage done by a level 8 fireball using fair dice. Suppose instead I want to use loaded dice. Well, here what I do is roll a single die. So here's a single die, 20% chance to roll a 6. Otherwise, it's a fair die. Now repeat 8 times. I'll have a variable called damage. You have to define your variables before you use them. So I'm going to start at 0 damage. Roll the dice 8 times and add the die roll to damage. When I'm done, display how much damage I did. So every time I hit the green arrow, it'll run this code. And the damage I did was 29, 30, 21, 28, 36. So that's for loaded dice. Now this is where scripts are really nice. Suppose I want to change the problem. Rather than rolling a level 8 fireball, loaded dice, let's roll a level 7 fireball. Change that one line of code. That's now a level 7 fireball. Suppose instead of loading the dice so that 20% of the time I roll a 6, I want to make it 35% of the time. That's a level 7 code fireball where the dice are loaded by 35%. And I could even change it to 8-sided dice. So let's make this a D8. Change all those. And this is, let's do 68. This is a flame strike. 6 8-sided dice. They're loaded. So that's kind of what scripts are nice for. It's really easy changing your code once you get it written. That leads into Monte Carlo simulations. This is one of the really powerful and useful capabilities of Matlab, is you can run Monte Carlo simulations. The idea here is, suppose I want to find the probability of an event. Like I've got my loaded dice on a fireball, what's the chance of doing 30 damage? Well, I can calculate that. When you get to ECE 341, you'll calculate probabilities like that. But not having any background on statistics, I can still calculate the odds using MATLAB. Here the idea is write code to run an experiment one time. If I can run it once, then run it 100,000 times. And then count how many times the event happens. The probability is roughly the number of times it happened divided by the number of times of events, like 100,000. That's kind of the definition of probability. So for example, suppose I cast the spell Ice Storm. What Ice Storm does is 2 8-sided dice plus 4 6-sided dice of damage. What's the probability of doing n damage, where n is a number between 6 and 40? What's the probability of doing at least 30 damage? So I've got, an orc out there, a really tough orc, that's got 30 hit points. What's the probability I can take out an orc that has 30 hit points by casting an Ice Storm spell? Well, the trick with Monte Carlo is first roll the dice once. So here's my 2 8-sided dice. Here's my 4 6-sided dice. Add them all up. And again, note in MATLAB, I can make the variable names anything I want. I could really make this confusing if I wanted to. That's not the point behind programs. Pick variable names that are semi-meaningful. So you kind of see what's happening. So when I take this code, run it, here's the damage. And actually what I would do is first time I run the code, take out the semicolons, like so. Take out the semicolons and run the code. So if I run this code, it says I have an error. Fix the error, run the code. Okay, so here's my 6-sided dice. Looks believable. There's my 8-sided dice. A little worried about 2 5s. Run the code a couple times to see that it's making sense. And 8-sided dice are numbers between 1 and 8. 6-sided dice are numbers between 1 and 6. Okay, that all looks good. Once that works, I can throw in the semicolons. That's for one run. Now let's repeat this 1,000 times. Now the damage is between 6 and 40, so this is how much damage I did. And indentation is really decorative, but that kind of helps you to know where you are in your code. So here's a for loop. I'm going to run it 100,000 times, 100,000 times, and keep track. If I rolled a 17, result of 17 is incremented by 1. If I did a 31, result of 31 is incremented by 1. Then do a bar chart. So when I run this code, it goes through this 100,000 times, and then eventually comes up with a result. So this is a bar chart showing this is how many times I got a 10, 11, 12, 13 out of 100,000 rolls. And note this is a nice bell-shaped curve. That's the central limit theorem, one of the most important theorems of all statistics, that says under very general circumstances, almost everything converges to this bell-shaped curve called the normal distribution. But again, we'll get to that later. What I can do with that then is say in the command window, what is result of 30? So I did 30 damage 3108 times. I rolled the dice 100,000 times. So that's roughly the probability of doing 30 damage with an Ice Storm spell. If I want to do 30 or more damage, let's sum them up. Go from 30 to 40. So this is how many times it did 30 damage, 31, 32, add them all up, divided by how many times I rolled the dice. There's an 8.7% chance that I killed that orc that has 30 damage with my Ice Storm spell. Again, that's a really tough orc to have 30 hit points. But anyway, okay, so that's kind of examples of scripts. And again, the trick is to first write the code to roll the dice once. Once I get that to work, throw that in a for loop. Now repeat 100,000 times. That's the for loop. Another example. Suppose two people are playing a game of tennis. Actually, not tennis, different game. Suppose two people are playing a match. A's got a 60% chance of winning the game. What's the chance that A is going to win the match if the match is best out of 5? Okay, best out of 7. That's a for loop. What it's going to do is going to start out where A is 0 and B is 0. That's how many games they've won. I'm going to play 7 games and 60% chance that A wins, so A won the match. Otherwise, else, B won the match. After 7 games, I'll then check. If A is greater than B, A won the match. So if I do that, display A, display B, display matches, A won this match 5-2. If I run this over and over again, I'll get different answers. That's the result for each match. Okay, so I can play a single match. Once I can play a single match, now repeat. Play 100,000 matches. So here, I'll play 100,000 matches. At the start of each match, each player starts at 0 games, and then check. If A is bigger than B, A won that match. When I'm done, how many times did A win the match? In that case, A won 70,913 times. So roughly, that divided by 100,000 is the probability that A is going to win any given match. A's got about a 70% chance of winning a match. And that's kind of the idea they do in basketball. It's the best out of 5 series, best out of 7 series, because baseball does that too. If the team is slightly better, only 60% chance of winning. If I played a single game, the better team only wins 60% of the time. If I play a best of 7 match, the best team's going to win 70% of the time. That's a for loop. And a for loop does a fixed number of loops. A while loop keeps on going until an event happens. So for example, suppose I want to roll a die until I get a 6. That would be something like this. I'm going to say this is how many rolls I had, starting from 0, starts in the loop, keep on rolling until I get a 6. So initially this is a 0, that's not equal to 1. I roll the dice. If the answer was a 6, I kick out. Otherwise, I roll again, roll again, roll again, keep rolling until I get a 1. When I do get a 1, I kick out, and then display how many rolls it was. And this is another way to do a display. This display displays some text, converts the number to a text or a string. And when I do that, run, 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 hit the green arrow, it took 2 rolls to get a 1, 4 rolls to get a 1, 19 rolls, 2, 4, 3, 2, 1, so on. That's a while loop. In theory, this could go on and on to infinity. Versus a for loop is a fixed number of times. So suppose I want to find out what's the chance or probability it takes me more than 7 rolls or more to get a 1. That again be Monte Carlo. Once I get this written, how many times it roll the dice until I get a 1? Now repeat 100,000 times. I'm going to start at x equals 0. If n is bigger than 7, greater than or equal to 7, increase x by 1. Now repeat 100,000 times. When I'm done, it took me 7 or more rolls 33,343 times, telling you the odds that it's going to take 7 or more rolls to get a 1 is about 33%. Again, you can calculate that when you get to ECE 341 random processes. But now, knowing nothing about statistics, I can use Matlab to find the same answer. And that's one of the beauties of Matlab. You can find answers using numerical methods, and that'll get you close. To get exact, you need to take the course. Another example. Suppose two people are playing a match. A's got a 60% chance of winning any given game, just like before, but now you play until a team is up by 3 games. So you have to win by 3. What's the chance A is going to win the match? And that's actually a really hard problem, because if A wins, then B wins, then A wins, then B wins, you're back where you started. I can solve that in Matlab. First, play a single match. So let's start out at 0 points. Keep playing until somebody's at +3 or -3. For any given game, 60% chance A wins, I'll add a point. Otherwise, I subtract a point. So I'm going to be kind of doing a random walk. If I ever get to +3, the match is over, A wins. If I get to -3, the match is over, B wins. So as long as the absolute value of A is less than 3, keep playing. Once I get to 3, I kick out. Now if I'm at +3, A won the match, otherwise it lost. So this is a single match. Try this, run the green arrow a couple times, and see that A wins, loses, loses, wins, 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 loses, loses. So far looks good. That's one match. Once I play a single match, now play 100,000 matches. So I'm going to repeat 100,000 times, starting from 0 wins. Play a single match. If A won the match, increase wins by 1. After 100,000 matches, see how many times A won. And A won 77,000-ish times out of 100,000. So A's got about a 77% chance of winning a match with this format. And this is a little bit better because the better team wins more of the time. But TV really hates this format because I have no idea how long a match is going to take. It takes it tough to program. They also hate it because once in a while, A wins 3 games in a row, and the match is over. I lost some advertising money. So there's another format. In tennis, I have to win by 2 games, but I have to play at least 4 games. So it's the first person to 4 win by 2. If A's got a 60% chance of winning under this format, what's the chance A is going to win the match? Again, this is a while loop. What I'll do is start out with A and B both at 0 games. I'll keep playing as long as the maximum of A and B is less than 4. Keep playing until somebody gets to 4 games. And for every game, A's got a 60% chance of winning, otherwise B wins. Once I kick out, I'll have another while loop. If I haven't won by 2, keep playing. So as long as the absolute value of A minus B is less than 2, keep playing until the absolute value of A minus B is not less than 2. So if I run this, hit the green arrow, I see that A wins 4-1, A won 6-4, A lost 6-8, A won 4-1. That's a single match. Once I can play a single match, now play 100,000 matches. So I take this previous code, stick inside a while loop, again starting from 0, 0, play 100,000 times, and keep track of how many times A wins the match. If I do that, A wins 73% of the time, about. So again, the way to calculate the odds is actually pretty complicated, but with Matlab, if I can play a single match, I can use Monte Carlo simulation to figure out the odds by playing 100,000 matches. That's really one of the powers of Matlab. So with that, you should be able to do the homework. And if you get stuck and don't really know what to do, what I would do is go to the ECE 111 page. That's under Bison Academy, ECE 111. Go under Homework Sets and Solutions. These are the homework sets and solutions from previous semesters. And the homework problems tend to be similar year after year. Change the numbers, so the number is going to be different, but same procedure. If you look at the previous solutions, that'll kind of give you an idea of how to approach the problem. And there's also YouTube videos where we walk you through these problems and homeworks. So in summary, MATLAB is a fairly friendly computer language. You can use it at the command window like a calculator. It adds, subtracts, multiplies, and divides, and it has graphics. You can also use scripts. Scripts allow you to try and modify code as you write it. MATLAB also is a programming language. As a programming language, I can do for loops. That'll let you run a set of code a fixed number of times. For example, I could do a Monte Carlo simulation. I can use if statements. If statements let you execute a certain set of code if a condition is satisfied, such as if the sum is 25 or more. And there's also while loops. I run a set of code until an event happens, like repeat until you get a 1. So that's lecture number 1 for ECE 111. Again, the point behind this course is to get you familiar with MATLAB. Again, MATLAB is used throughout the ECE curriculum, and the goal is by the end of the semester, you'll be fairly proficient with MATLAB, so when you're given a problem in a course later on, you'll be able to write the code for it. That's lecture number 1 for ECE 111.